So we're going to start gently. I'll give a bit of introduction, but this is welcome to the first webinar for SOFLUX. So SOFLUX is the Southern Ocean Air Sea Flux Working Group. And this is the first time we've ever tried to do a webinar. We really wanted to have an opportunity to let people hear about and discuss some of the efforts to sustain and improve. I'm seeing a chat message that people can't hear me. Is that true? Are you having sound problems?
I can hear you, Sarah.
Okay, thank you. Good, so we'll hope that people can hear. We really wanted to have a chance for people to hear about and discuss efforts to measure and improve the measurements of air sea fluxes in the Southern Ocean as part of SOFLUX. So we've planned to try and do something on sort of a monthly schedule. The goal is to give precedent to the speaker. So the speaker gets to choose the time zone, which means we expect the time zones will switch around quite a bit, with the goal that at least the speaker should be able to be coherent, and other people, if they don't want to get up at 2 a.m. or whatever time it is to hear the talk, can hopefully catch up later. But we hope that we'll have really good discussion as part of this today. If you have questions, we'll should have time for questions at the end. You can put questions in the chat or raise your hand. So our speaker today, at any rate, is Eric Schulz, who's going to give us an update on the Southern Ocean time series observatory. Eric is a principal research scientist and the ocean modeling team lead at the Bureau of Meteorology in Melbourne, Australia. And he's been doing a lot of the work to keep the SOTS mooring operational. So Eric, if you want to go ahead and get started.
Sure.
Anxious to hear from you.
So funny you should say what my job was, that I've just changing my job right now and moving back into observations and data, which aligns more closely with what I did when I started working on this SOTS area 10 years ago. So that's kind of closing a loop a little bit there. I'll try to share my screen and let's see how we go with that. Okay, and I'll go full screen.
Looks great.
Okay, full screen.
Yep.
Thanks, Sarah. So as you say, this is an update on the Southern Ocean Time Series Observatory. So I gave a talk to the SOFLUX group when we first got together about 5 years ago in Frascati. And so that was really more of an introduction. So I'll go through, this is sort of building on that essentially. And just listing sort of the main contributors to this, well, to the program and to some of the images I'll show here. So myself, Elizabeth Shadwick, who's at CSIRO, and leads all the biochemical aspects of the work. Catherine Edwards on the Sediment Trap work, and Tom Trull, who's sort of the founder of this site and is retiring now, so stepping back. Elizabeth taking up that role. Of course, we have a bunch of labels down the bottom there for the various area groups that support us essentially. So motivation, this is just a very standard slide. Obviously, Southern Ocean, pretty important for the global climate system, but very poorly observed. This slide's quite old, and some of those things under construction have come and gone, and the wish list has stayed a wish list for some of the areas, but it's certainly very very undersampled. And another old slide, essentially this is an example of, if we're looking at something like some kind of a gridded product, like in this case SOFLUX, we're going to look at it, compare it to ground truth it against buoys. In this case, you can see the ground truthing is very focused in particular geographical regions, and elsewhere we just kind of big question mark really. So Southern Ocean time series with the red dot on this map, 47 south, 140 east, really got going around 2010. We've got some earlier stuff, which I'll briefly touch on. That's when the main concentration of effort started. So yeah, so IMOS facility, so IMOS Integrated Marine Observing System, that's an Australian federally funded, I guess, partnership of lots of marine agencies in Australia. And we're centrally funded to provide ocean marine observations. So that's been a really good thing for Australia. I think other countries probably may look at that and say, "Oh, I've done really well." I think we have. Of course, the focus of that changes over the years, over the decade as well. So potentially moving more coastal. It's not all about climate and open ocean. So there's always an interesting dynamic there for us to keep sustaining what we started. So at the site we have multiple moorings. Of course, the data is freely available. That's part of what we sign up for when we get funded to do this kind of thing. And we also try to make our platforms available for other researchers and other instruments to be deployed. So moorings are really expensive to put in and maintain, so we want to maximize the return on those. So if other researchers want to come along and put their gear on there, we'll try to accommodate that if we can. Designed for annual visits, so ship coming out mostly, or pretty much always from Tasmania, Hobart. It's a little triangle bit of land at the bottom of Australia there. And yeah, so it's in the subantarctic zone. So that's just just inside it on the green zone on the map there. So year-round strong winds, always large waves, long fetch, deep winter mixing. It gets cold. So it's a strong forcing of the ocean. So the fluxes are pretty important around there. And so of course that's also part of the formation of the subantarctic mode water, which sequesters a lot of CO2 and heat into the deep ocean in Southern Ocean. So it's an interesting place for us to be positioned and to do some science. So as I said before, multiple platforms. So part of the reason for that is it reduces risk a bit. So if we have this site, if one mooring fails, then we don't lose everything for that year necessarily. So yeah, we've got Sediment Trap, so the SAS Sediment Trap. It's a picture in the middle there, that's upside down. I'll talk a little bit more about that. Then we have the Southern Ocean Flux Station, so that's a large surface mooring on the left there. It's a Woods Hole Hui design. And then we also have the Pulse biogeochemical mooring. So that's the picture on the left. That was it's a very small surface signature. The package suspended 30 meters down that was doing biogeochemical work, so a lot of collecting water samples. In recent years, we actually merged the Pulse mooring with the SOFLUX mooring, the Southern Ocean Flux Station mooring, into one. And a lot of that was about essentially efficiencies in operating, so saving money in building every year, saving ship time out at the site. A bit more eggs in one basket, but balancing up our risks there. So Sediment Trap mooring, for those that don't know, essentially it's like a large funnel, like a rain gauge, but underwater, and any particulate matter that falls down is collected into the funnel and caught in these little cups that you can see in that middle picture there, and they rotate around periodically, so you get a time series of stuff you're collecting. And then that is then recovered and annually and taken back to the lab and analysed for the various bits. So so we just want to get track that particle flux, measure at 3 different depths. 1,000, 2,000, 3,800 meters. And it's just some results from Catherine. I can't talk to them very much, but you can see on the picture on the right there that she started this site back in 1996. There was a sort of burst of activity there, but then nothing much until 2009 when IMOS really took off. Obviously, the deeper sites, it's a more sort of integrated view of the particle flux, so it's quite a lot smoother compared to the nearer surface measurements. So SOFS mooring, I feel like I'm missing a picture, but I can talk without pictures. So on the right there, that's that's this team that deployed the latest SOFS. They're up to SOFS 10 now. It's just gone in April this year. So we've been going since 2010, and we're essentially on the 10th mooring. So yeah, large surface float, slackline design, instrumented, the top 500 meters temperature and a bit of salinity. A biogeochemical package at 30 meters down, small one, and then a larger set of water samplers and so on, just directly under the buoy. And on the tower, we do all the meteorological measurements, PCO2, all our heat and mass flux type measurements. Large buoy, so weighs over a ton, anchors big and heavy, 3 or 4 ton, 4.5 kilometers water depth. So so deploying in Southern Ocean, it's typically rough there. You don't get many lulls where it's calm enough to work, and even when you do, it's still rough. Big heavy pieces of equipment we have to move around. There it is. I tricked myself with my picture popping up afterwards. So that's a cartoon of essentially what it looks like. So I don't really have much to add, I don't think. So here's some observations of PCO2. So we deploy a map code system from NOAA, from PML, and we've got data here back to showing back to 2012 up to about now. So 8 deployments. So so as we say, they're one of the longest deployments in Southern Ocean for a fixed location. And I think for the SOFLUX mooring, it is now the longest one. And I'll talk more later on a bit about some of the challenges of making it the longest one. So we're heading for a decade of data. So it's time to when you start all this thing in the first year or so, you get all these wobbles on the you get a time series that's supposed for a year or two, and you're sort of like, well, that's all very interesting. What does that mean? And you get up to a decade, and you start saying we can look at the interannual variability. And can we start seeing trends? And I guess there's a question mark on that. Can we see a trend? Maybe we'll have to just keep looking, I think. And so then of course we're at a fixed location. The water around us does move and do things, so we can start looking at other influences on the site. So for just on the left there, we're talking about the East Australian current that comes down the east coast of Australia. That's penetrating quite a long way south. Does come past our mooring site at times, so we do get influences of the EAC right down to where we are. So we start to see signatures of that. So that's something we can start looking into a bit, and also looking at the influence of the southern annular mode on the amount of mixing that's occurring in our region of interest, and implications of that for our CO2 exchange. So here's just a plot of incoming shortwave radiation. So this is the full series that we've got for our surface observations. Each colour is a different deployment. So you can see lots of, very frustrating on a time series, but you end up with lots of gaps, and each of those gaps tells a story about some failure that we had, whether it be instruments stopped working, or the mooring broke loose, or in this case, I've got a mark in there when we swapped over ships that we used to service a mooring. There was actually a gap when there was no ship for a year or so, which really has a big knock-on effect to our moorings. So of course we can do more things like aggregating up those data into monthly averages, which is what we're showing here. So you can start looking at, so each of these on the picture, the diagram on the left, each of those colours is a different deployment, a different year, and so you can start to see what does the month July look like across all those years that we've had deployments. And in this case, you can actually see that we've only got 5 Julys worth of data there. This filtered a bit, so we don't. If there's only 1 or 2 days, we throw it out. If you have say 15 days, then you've got a month's worth of data. So so we can start seeing, is there a strong annual signature there? And then on the right, you can see looking at median and standard deviation of those net heat fluxes. So now that we've got 10 years of data, this stuff starts to get a bit more interesting. We can really start to dig into that a bit more. So I'm not going to talk much more about the actual data, but a bit more about the mooring, and particularly the SOFS mooring. So I should say that the SAS mooring, so the Sediment Trap mooring, is a well-proven design. It's been used in many places and has been very robust and successful. And for us, we haven't needed to do much with it to make it work well. So we haven't tinkered with it much. For the SOFS mooring, so the large surface float, that was fairly ambitious goal to deploy that in the Southern Ocean, and so into Woods Hole for a design, and of course we had to tune that up for particular conditions we have. So just a list there of some of the things that we considered. So obviously it needs to operate in rough conditions. We went for that slack line style of mooring, just to reduce tension in the line. Very low tech approach. So there's no subsurface telemetry, for example. It's just heavy chain at the top. Light instrument load. After the first year of having a light instrument load and everything going really well, we increased the instrument load and managed to break things. So we quickly discovered that we were closer to the edge than what we would like to be and had to pull back. So do a fair bit of load analysis, static load analysis, winds and currents. Looked at the cyclic fatigue analysis using some software packages, and now we can determine what the lifespan is of all the various components in the mooring. So saying as strong as a weakest link, so right down to individual shackles, which one's going to break first, and ideally we want that to last 4 times longer than what we planned for, which is the 12 months, so a 1-year deployment. Of course, we want to be able to recover the mooring after we put it in. So looking at more than one way of getting it back. So often we get to the Southern Ocean and the conditions aren't ideal, and we have to wait for calmer weather, and maybe you don't get calmer weather and you still have to recover a mooring in 3 or 4 meter seas, for example. So having good ways or different options for how to recover your mooring from the ship is pretty important. Also, particularly for the instruments above water, we want redundancy, so we have double of all the net sensors. And typically, by the end of the deployment, after a year, we've lost at least one of something. Sometimes half of all the sensors have stopped working. And my interest is in doing the fluxes, so we really need all of the observations to be able to do, say, net heat flux. If you're missing wind or air temperature, then or any one of those things, you kind of can't do what you want. So that's really important. And of course, we have GPS trackers on top and bottom, so if it breaks loose, we can track it down. The diagram on the right is just showing the wave climatology that we used to do our cyclic fatigue analysis. So that was based on wave models, and we were expecting the most frequent waves to be around that 3 meter significant wave height. And we measure waves on the buoy, and this is the first few deployments, SOFS 1, 2, and 4, and just histograms of the significant wave height in the top panel there. And so they are in that sort of 3 to 5 meter, 3 to 4 meter significant wave height is typically what we were seeing. Obviously, individual waves can be quite a lot larger, of course. We get them up to whatever 15 meters or something like that. The wind wave direction is pretty consistent. The southwest waves coming from there seems to be pretty standard. This is just this is a bit of a closer up of the instrumentation on top of the tower. This is actually the original SOFS one. So this was early days when it wasn't very crowded. We have a lot more up there now, especially a lot more antennas. So we have a lot more equipment down in the buoy well and loggers, and we're transmitting back quite a lot more information. But this is the basic MET suite of instruments to do our fluxes. And as you can see, it's two of everything. So this is just some talk a little bit about the extreme environment. So obviously you'll know about marine environment's pretty rough on equipment. So here we similar kind of thing. We at times have seen significant corrosion of components and some breakage as a result. Of course, biofouling on the surface float's quite significant. And then fatigue. So the photos on the bottom right are showing we have a transition piece where we go from wire rope to synthetic rope, and that's a troublesome point at that transition, because you're going from a stiff member to a flexible member, and that acts like an elbow. So all the motion, all the stress goes through there, and it wears on that point. So trying to smooth out that joint to be a gradual change from stiff to not so stiff is an ongoing task. So we source those pieces from Hui, and they've been pretty good in recent years. I think we've had failures there for a while now, but of course, as soon as we solve a failure in one area, we find another one somewhere else. So you're always chasing things around. So there's another point is that it's very rough in the Southern Ocean, and we do see damage to instruments on top of the tower. So we're 3 meters up, but we lost the tops of our rain gauge funnels. That's a photo on the left there. It's possibly a bit hard to see. We've had the whole the mounting struts on our instruments bent right over. So you can see that's that bottom picture there, and sonic anemometers. We've had the arms of them bent over. Assume it's waves, but who knows? We put stuff out there. We come back a year later, and in between, we don't really know exactly what happens to our mooring. So just to add on the sonic anemometers, we prefer to use instruments that don't move. So we don't go for a prop vane anemometers, because the propellers get ripped off really fast by the waves. So it's no moving parts is the preference there. So I think this is actually my final slide. I have no idea how much time I've spent, but oh yeah, not too bad. So I gave some thoughts on the SOTS program 5 years ago, and this hasn't changed much, but I thought I'd go through them anyway. So there's this goal for SOOS and I guess SOFLUX to have sustained observations in the Southern Ocean to measure fluxes. And we all come up with lots of plans, but it's really hard to actually enact those plans and make them stick. Doing field studies, that's okay, but going beyond that to something sustained in the same place year in, year out, it's really tough. So I'm saying reason for success. I think we've been moderately successful, but we've had lots of ups and downs along the way. So logistics at the top of my list, really. So I didn't pick this site because it was great for fluxes. I would have been happy with anywhere where there wasn't a lot of measurements of fluxes would have been good for my interests. But going to a site that was already established by CSIRO with Tom Trull, and also being a site that was relatively close to the home port of the ship that was going to service the mooring, is really, really important. So, there's no point putting gear in the ocean if you can't service it regularly with a ship. And in the past, we have to fight every year or 2 or 3 to get ship time to do this. And we compete with everybody else. So, so making it logistically easy for the ship operator really helps us. So saying 36 hours away from Hobart. Strong collaborations with other mooring groups, particularly Hui in the early days, gave us that big leg up with us having to go through a really big development phase. So we were funded to collect observations. We weren't funded to do a tech development. A little bit that happens, but that's not really what it's about. So that gave us a big leg up. I think having multiple research programs involved, or so multi-institutional support domestically, is really important. So, I showed that slide at the start, but essentially, CSIRO, University of Tasmania, Australian Antarctic Partnership Program, the Bureau of Meteorology, all working together. So, typical thing, one institution listens to what another one's saying more than to their own internal members. So, so CSIRO, just if they want to internally, Elizabeth wants to beef up the CSIRO support internally, she said, well, the Bureau is involved and they're depending on this stuff, so let's get on with it, and vice versa. So that's quite strong, not just being a single institution. So before, so a platform for other users or other researchers. So as I said, we've got the PML, MAPCO system. We've had a fair bit of wave stuff on there over the years, some domestic, some international. Right now we're gearing up to do some SWAT satellite CalVal work. So we're positioning our mooring in just the right spot for that, and got some researchers putting gear on to be able to do that validation work. Of course, we also actually put a fair bit of effort and resource into data management. So we don't just, it's not just all about the gear and the technology and the observations. We do collect them, we do process them, we do quality control them, metadata, and deliver them to places for them to be used. So the IMOS that funds this, they also fund the Australian Data Ocean Network, which is that's an ocean portal for data. So that's where it all ends up. And we also have some real-time capability. So the stuff on the surface float, we send back hourly or 3 hourly observations, and of course when we collect the mooring annually, we get the higher resolution data that's being stored on board. So that's useful for us to monitor what's going on. Not that we can always do much about it, but also where I'm from, it's an operational agency where we do real-time forecasting. So being able to use data, feed that in there is another use for the data, which is pretty important. So challenges: sustaining ship time and the funding for the equipment. So if you get one of those, that's not good enough. You need to get them both. But often, to get one, you have to show that the other one's kind of there as well. So it's the chicken and egg thing. So that's quite a juggling act. That Tom Troll's done that really well over the last decade or so. It'll be a future challenge for Elizabeth and myself to be able to continue doing that. Staff participation in the annual voyages. So really we could do our work fairly quickly, 10, 12, 14 days. We can do what we need to do, but often we are buddied up with other research experiments and groups on the ship. So we might stay out, could stay out for up to a month. So that's a bit tricky for us. Of course, when the mooring breaks and drifts off, we need to go and get it. So finding a ship to do that in the Southern Ocean is not easy. It's a relatively large mooring, so you need the right size ship. And also there's a lot of ships aren't equipped with the right kind of gear to be able to do a recovery like that. Second last one, which is a big one, is just maximizing the uptake, the use, the integration with other research programs. So we're funded to collect the observations and make them available. We're not funded through IMOS to actually do research. But of course they want to see that occurring to justify why investing money in collecting these observations, need to be contributing to something. So that's a constant challenge for us, is to find partners to work with. And then the last one, which is just a little bit of a tail on that, is that if people do use the data, we need to know that, so we can point to it and say, hey, this thing is relevant. Others value it and make using it to progress their own science and so on. And that's I think that's it. Yeah, there we go.
Well, thank you very much. That was great. We have time for questions, and I would encourage people to pipe up or raise their hand or put questions in the chat, whatever works. And maybe just to get things started, I'll ask, you mentioned that you were trying to keep track of how people are using the data. Do you have methods for doing that, or are you counting on people remembering to tell you?
So, so I must make an effort to track data, and I suspect one of the most successful ways is just to scrape the internet for, for things like IMOS or SOTs or SOFs, and come at it that way. They ask us to report any usage that we know about directly back into IMOS, but what you don't know, you can't report on, and it's very, it's quite an effort to really do that well. And sometimes people come and say, "Hey, I want to use your data for something or for some project, student project," and you point them at it, and you never hear back, so you don't really know how it went, or did they get anywhere with it, or what happened. So yeah, I think it's just it's tricky because so some of our data gets taken up into very large efforts to create huge global data sets of whatever, all kinds of stuff, and our contribution to that is very small, but important enough. But our funding agencies always pushing us to get all those acknowledgements into the papers that are published, which is difficult, I think, because the people writing the paper read it. IMOS is just one of 50 sources, and they're not going to write a big long attribution to who funded it and all that stuff. So I think that's ongoing challenge.
Yeah, I know. I've seen some of the efforts in OOI in the US, and it's been hard to track what's actually happening with the data.
Yeah.
So, Marcel has his hand up.
You're on mute. Yeah.
Hi, Eric.
Hey, Marcel.
Yeah. Good morning. Well, good afternoon for you. So you were talking a little bit about the sensors and how they can potentially be harmed by sort of wave action and things like that. Thinking from a perspective of applying these sensors to autonomous vehicles in the Southern Ocean, do you think that the sensors you've used would be sort of valid for that purpose? Or do you think you need sort of better rated sensors? So, at least I'm thinking for the heat fluxes perspective, but I guess this applies to other as well.
Yep. Yes. So, so some sensors are more delicate than others. So probably the worst is humidity sensors. I'm not talking about CO2 here. I'd defer to somebody else for that. But so for heat, if you just want to measure air temperature, I would be going for actually a seabird sensor that's designed to go in the water, but you just put it in the air and put a shield around it. They're super robust. Doesn't have to get wet. SST is fine. They use seabirds for that. Radiation's really good. I don't think we've ever had much of any problems with the radiation sensors. So they're using Epleys, and I think we use a Kippenzonen as well now. And yeah, the winds, sonic's pretty good. So it just depends a bit on the sensors. As I said, these are supposed to be 3 meters above the water, so they're not getting, inundated regularly. If you go closer to the water, it's hard to say. And I'm not sure there are better, more robust sensors. But you can ask around. Lots of people are deploying stuff.
Yes. Yeah. So you think relative humidity is then the issue in terms of getting the heat budget?
Yeah. RH is troublesome. If you get, they have a Teflon sock over the sensor. If once that gets seawater on it, then you get salt on it, and then it doesn't measure properly anymore. So they tend to be difficult to make them last. There is lots of people have tried many different things and various levels of success. Of course, doing something on a ship first is easier because you can have it attended and trial things for a while and have a tech go out and wash things or whatever, replace things. But once it's autonomous, it's really stuck with it.
Okay. Cool. Yeah, that makes sense. Thanks.
To continue on that vein, there's sort of an ongoing puzzle about whether you're working with the bulk parameterizations, I guess, And there's this ongoing puzzle. Is it possible to do things with flux covariance systems? Would
Yeah.
that survive?
Yeah, I think so. Well, so I think
I should say it's in the specs for the OOI Southern Ocean mooring, and they broke them on deployment. So they didn't get much of an answer. for
right,
most
that was
of
due to
deployment period.
human failure with deployment. Yeah,
Right. Just
I mean, I think there's been a number of deployments of eddy covariance systems on moorings, but I think they've been more campaign based, so not too long. I mean, you know, I've got aspirations to try that on the SOFS mooring, and so you know, the sonic anemometer part of it would be fine. Maybe the temperature fluctuate, you know, the temperature, it would be okay too. Once again, community is a bit tricky. So it's probably be okay. And maybe only get stuff for a few months before it stops. So of course, with you know, as you know, well, you probably know, with the covariance need to capture the motions of the sensor as well, or the platform. So there's a bit of an extra coding technical challenge.
yeah.
And a question. You mentioned that you've integrated the biogeochemical pulse mooring onto the SOFS mooring. Which sensors do you have on there that you've moved across?
So is Elizabeth online? She could answer that better than me.
Yep, I'm here. So on the, in the float, I guess there's a nitrate sensor, there's a McLean RAS autosampler that takes discrete samples. And then there's oxygen, chlorophyll, PAR, backscatter, and then basically a repeat of all of those except the discrete sampler at 30 meters. And of course, there's a PCO2 system on the float. And then at 30 meters, there's also a gas tension device, so you can make oxygen budgets and go for net community protection. The best place to look for the specs, I guess, Eric, maybe you can point people to the mooring diagrams are actually on the IMOS site. So if you follow through to SOTS on the IMOS website, you can get a diagram of the mooring, and hopefully all of the sensors are listed there.
Cool. Yeah, I'll have a look. Thanks.
When you can't find it, come back to us and we'll point you to it.
Noted. Thanks.
Did I see a question about real-time stuff?
Yeah, there's a question in the chat from Karen Westwood. Do you receive any data in real time from the mooring, or is it logged and downloaded later on?
So from the surface float, we receive real-time data, either hourly or 3 hourly, depending on what it is. And so that's available, you know, within a day to everybody who wants to go and pick up day files.
And you said from the subsurface mooring, you don't try and relay it in real time.
No, we don't. There's no telemetry for the subsurface. So there's, you know, there's whatever we measure in the buoy, which can be just under the buoy, that's available as well. I think a 3 hourly. Not sure all the parameters there, but we could provide information on that. But anything deeper, we don't. We just have a big heavy chain to make sure it doesn't break.
But presumably your WHOI partners have been playing with how to telemeter from the subsurface mooring, so that could be developed if it were a priority. Yep.
There's lots of there is various. There is some solutions. I think for us, you know, any big change like that is a risk, and we just haven't felt like it's worthwhile getting that subsurface telemetry. So the downside is, of course, if the mooring breaks near the surface and you say lose your 30-meter package, you're probably not going to get anything out of it after it's been down at 4.5 kilometers. It probably won't survive that, so you lose all that. But other than that, don't really need real time for a lot of that stuff.
So I had one additional question. I think one of the issues that's come up a lot in both in the community effort that Megan Cronin led for Ocean Obs, and before that in the Frescati discussion, is this question of how you measure, how you get more instruments into the Southern Ocean. What can be done with wave gliders? Is it possible to survey around a mooring to get more spatial sampling? And maybe more broadly, just how much do fluxes change, and how close should flux moorings be to see variability across frontal structures? Do you have any views on how to address that? Would the ideal thing be to put in more than one mooring at some optimal distance apart, or to put out a bunch of wave gliders to survey in the neighborhood of the mooring?
Well, I think, so moorings are very expensive and a big effort to maintain. So I wouldn't advocate for that. I mean, I guess you could do it as a field study where you put one out for a period of time just to see. Yeah, I mean, over the years we have deployed, gliders and Argo floats, past profiling ones, and all those kind of things when we were at the site. And there's been technology challenges. Like with early gliders 10 years ago, they weren't very successful at all in the Southern Ocean. I think the what do you call them, the boat things that they have now, the sail drones. Yeah, so I think some of the earlier ones, those Southern Ocean haven't done very well, but I think they're redesigning and doing better now. So I think there is potential to do that. And I think, for us to answer our flux question, we need to be using a range of different platforms all working together. I mean, right now we go out with the ship, we collect obs on the ship, fluxes on the ship as well, of course, and we hang around for a while. So we get a bit from that, and we do put things over the side. Yeah, but I think we need to do more of that. And I think one site in the Southern Ocean is probably not enough, but 10 is probably too many.
Maybe too many logistically, maybe not too many
from
a data standpoint.
It's all about logistics from my point of view.
Yeah.
The science doesn't matter if we can't actually get the measurement to stay there.
Right.
What's the point? So, and getting the backing is hard, and to sustain it. It's okay. You can get backing for a year or two, do something exciting, but there's a constant challenge for us. For instance, when we go out in the ship, the ship wants to do great science and show that it's done great science, but we're kind of saying, well, we just want you to go out there and chuck in the next buoy and bring back the old one. We're just using you as a taxi, if you like. But they don't want to hear that, of course. So there's that constant thing of trying to demonstrate that doing this somewhat boring stuff actually is, does have high value in the long term. But it's not the new discovery every week kind of thing. So it's quite, it's quite challenging. But I do think, because we go out to the same place every year, there's lots of opportunity there for others to come along on those voyages and do some of their science and merge it with ours. We're in the same place. We get that sort of temporal view, but we don't have the spatial view really. So looking at ways to combine that, I think is valuable.
Yeah.
And I think the other thing just with the autonomous stuff is that sometimes it may be potentially it's quite low quality observations. So I know, often they'll put out some, sort of automatic weather station type sensor, which really is pretty marginal for doing fluxes. But if you have it going past, a high quality mooring, then we can, use that to ground truth, the autonomous vehicles and so on. Try to, get the best of both worlds there.
Great. Are there other questions from anybody? If not, thank you very much, Eric, for starting this off. I think we were supposed to make announcements about reminding people that if you're not signed up for the SOFLUX email list, or if you want to stay up to date on SOOS activities, you should subscribe to the appropriate email lists, and Alice has put the information in the chat so you can grab it there and get yourself signed up if you're not already. And we'll look forward to seeing people at the next SOFLUX webinar in whatever form it takes and whatever time it ends up being.
Do we know what the next one is?
We're going to try and combine with the SOCOM annual meeting.
Mhm.
So there'll be a set of talks on flux related issues, I think on the Wednesday morning, the second week in June, Wednesday morning, US East Coast time. And we'll try and get those available for this discussion group as well. And then we're looking for a volunteer for July. So if anybody wants to share something, we'd be really grateful to hear about what's going on and what's on your mind. So thanks everyone for coming.
Thanks for
Thanks,
leaving us
everybody.
in.
Yeah.
Okay, goodbye.